All right, welcome back, everybody. Our last session of today is Karl and Philip. Karl is in Austria. Philip is in Germany. I've determined that now, and they're going to take it. They're going to take it from here, and I'll hand it over to you guys.
Thank you, Armin.
Thank you, Armin. So let us start with a quick introduction. My name is Karl Donaubauer. I'm from Austria, Vienna. I'm an Access developer for 25 years or so, but I'm also a certified data protection officer. And I'm doing consulting about GDPR and also presentations. And I'm an MVP for Access for some years. Phil?
Yeah, hi. I'm Philip Stiefel, and I work with Access for more than 20 years now. And many of my key clients are from the financial services industry. And in that context, I got a lot of issues regarding data security, not just with the GDPR, but beyond that regarding governmental regulations and stuff. And so that is my background for this topic.
Well, our starting point to reassess the security of access was the GDPR 2 years ago, the General Data Protection Regulation. That's a European law to protect personal data, and it requires something from us as access developers too. For example, it requires that we use state-of-the-art in our software and services, and that we provide an appropriate level of security to our customers and to our software. And it also mentions some technical details and techniques like pseudonymization, encryption. And Philip and I and the third colleague from Germany, Bernd Jungblut, we have co-authored a GDPR white paper, GDPR for database developers, and you can download it from this URL. It's free, and it's especially meant for Access developers, SQL Server developers. So this is our starting point to reassess the security of Access. Well, if you want to provide your customers, your clients with a secure access application, what are you doing? These are the basic things. You will provide them with a secure UI. That means you will use an auto-exec macro and or start form. You will hide the built-in standard ribbons. You maybe show your custom ribbons or no ribbons at all. You will hide the navigation pane. You will disable the special keys like Shift, F11, and the keys for the VBA editor. And many of us also build some custom user guidance. That means we read the user login, the Windows user login, put in a table, and read the permissions of the users from there. So they can see this form and this not, and they can have this data and that not. That's the usual basis we use. What else? If you are the administrator or have a good connection to the administrator, you can do more. You can restrict the permissions on the directory, on the folder where the ACCDE and the access application lies. Well, essentially, you can restrict it to the application users, but we all know the users need to write and delete permissions in order to manage the log files. What else can you do? At many of my clients, I use the terminal server, some terminal server like the Windows Remote Desktops or the Citrix, and it has plenty of options to restrict the direct access to the access files. That means you can hide the whole desktop, just give him one single application to use. You can hide the Windows Explorer, etc. So these are the things you can do outside of Access. Now we go into the core of Access. The most important thing we have there is the database password. Believe it or not, and these are the pluses of the database password, the advantages. It has become much more secure since the change from MDP to ACCDE as standard format. That means with Access 2007, it is now protected or using an RC4 encryption, using a 40-bit key, and you can extend this key up to at least 128 key. This is all described by Wayne Phillips, which many of you may know. We have a link here and you get the slides. You can see a lot of the details. We can't go into detail now, but read his page and there you can see how you can make it even more secure. That's maybe necessary. RC4 is not the latest and the greatest. It's 25 years old and not 100% secure. However, it's still secure and good enough to force the crack tools, all the crack tools, to use brute force to crack it. They only have the option of brute force. I will show it in a minute. Well, we are at the demo and I will share my screen now. So this is the tool I will use, and we can have a look what it is. It is the Password Kit Standard. Password is the most famous company, I think, for cracking passwords. It's an Estonian company, so European, but it has an office in California too. It works for government agencies in the US and all over the world, so it's a really renowned company. The most famous cracker also for Access and Office files. Let's have a quick look at their homepage. So this is the homepage of Passware, and you see the different editions. And if we have a look here, I have this edition here. Also, it says Office documents are supported here. But if we have a click on it, you see that's Office for Password. It's the same experience that you would have at a Microsoft site. There is no access at the Office sites, or only on the second page. It's Word, Excel, and PowerPoint. So we have to go to other common file types. And here we find Access. And you see that this is the first edition that supports cracking. Oh no, by the way, it's not cracking, it's retrieving the password, of course. Yeah. Let's have a look at the cost. It's the first edition that is useful for Access, costs 79 euros or $79. It's the same price in dollars. So let's have a look at the 80 plus files it can crack, file types it can crack. And if we go down to Access, there are two flavors of Access files. You see all the MDB files here, the MDB formats from Access 2 to 2003, it says instant recovery. So no problem at all to crack it in a second or a few seconds. Whereas if you look down here to the ACCDE files from 2007 on, it says we have to use brute force and that is slow. We even use the graphical processor that makes it faster, but it's still brute force and slow. By the way, 365 is included too. It's just not listed here. So let's have a look at the cracker tool now. I browse for a file to crack it, to retrieve the password, of course. It's just a normal ACCDE I use here. And I take it. And now it gives me several options for the way to crack it. How do I want to do? I say I will run the wizard to show you some options, because you can help the cracker to be faster if you know something about the password. Maybe you really have forgot it, or your client has forgotten it, and you still can help him. So is it one dictionary word? Do you know this? Is it more than one word from a dictionary? We say we don't know. So next option would be the language. Is it an English word, maybe a completely different word? And that is not only because it then looks in this dictionary, it's also about your keyboard. What kind of keys do you have? Do you have some special keys of a special language? Like, for example, Greek would be completely different than English. We just take English because we don't know much about the password. And here's another option screen where you can help him, the tool. You can say, I know that the password has this and that length or some kind of pattern, you remember, maybe you used a name or something. And if it was all uppercase or lowercase, or I don't know, we leave it as it is. That's the standard configuration. And we say, okay, please recover my password. I have lost it. What happens is that it goes through a dictionary. It starts with 3-letter words, with 3 characters, and it goes through it. And here you see we have already checked more than 1,000 words from the dictionary. It has a dictionary behind that has about 800 words in it, 800,000 words in it. and it has the same dictionary in different languages. You could also say, I just want to use brute force here and check all possible combinations. So you can do a lot of settings here in the cracker. I just let it run. We are at the 4 character words, and I think I can already reveal that I have used the 5 character word here. So we will be there in some seconds. The speed isn't the best here. My machine is not optimized for this, and I share my screen now, so the graphical processor is occupied. If you have a real good gamer machine, this would just last a few seconds, like the crackers usually have it. But we are already at the 5-letter words, and we will be done in a few seconds, I think. Oh, whoops, we have it. So here's, surprise, surprise, that's my password, Stein. And I can copy it to the clipboard, and I can go to the file, and we'll have a look if it really is the correct password. I copy it from the clipboard and say, okay, and I'm in the application. So don't use such a silly password. I'm going back to my slides to show you some more about the passwords. I have to stop my screen sharing, one moment. I can see the slider, sure, okay. Let me take the next one, yeah. What you see now is a table of passwords. It shows how long would it take a hacker to crack your password. So I think you can't forget every password that has less than 8 characters. It's just not secure enough. As I told you, this was a slow machine compared to the things that the hackers use. It would have lasted a few seconds to get that Steam password out of the database. Let's have an example here. Let us take this. If you have a 9-letter password, like let's say access365, that's with uppercase, lowercase, and some numbers in it, it would take him 3 days to crack it with brute force methods. Well, I can imagine a hacker let the machine run 3 days if there's something really valuable behind the password. But let us take the next line. This is for 10 letters. And for example, it could be the word access 2010. We again have uppercase, lowercase, and some numbers in it, and it's 10 characters. So it would take him several months to break through, 7 months. And I can't imagine a cracker have a machine run 7 months. It would have been very valuable to crack such a password. So it is decisive that you use long enough passwords and mixed passwords, what we always hear when it comes to passwords, but it's really like that, also for the Access database password. And what we can say is that Access 2010 is more secure than Access 365. Okay, I had to make that joke. In the upper right corner, you see a link, how secure is my password? It leads you to a web page where you can test your password, and it immediately tells you this is not secure, we will crack it in a second, or we will need a month for it. So it's an interesting link. Let me come to the next slide. There are also downsides to the password, to the database password, and this is the negative list here. We have only one password for all users. That's a real problem, a security hole, because anybody who knows the password can come in and read everything, virtually everything. We will show that later. The next problem we will have is there is a bug in the password. How they built the password in the Access team. If you link tables from a backend and you have a password on the backend, you are restricted to 19 characters. And I had the cases at a client where they had a 20-character password and it didn't work. They couldn't use the linked tables anymore because they always got the message, not a valid password. So this is a bug. You only can use up to 19 passwords if you have linked tables. I reported that to the Access team, but it's still not fixed. And another problem with the database password is if you have linked tables from the backend, you can read the password in plain text from the connect property of the linked tables. So you just have to have a look at the linked tables at the connect property, or you could read it from MSys objects where it is visible too. So that are some security holes in the database password. So if you have a setting where your backend is an access file, and your front end is an access file, you have to do this. You have to secure your backend with a password and your front end with a different password in order to close the file chain. Then we are again at that situation where they have to use brute force for both of it. And it may last really long if you take secure passwords. So that's the story about the database password. Phil?
Really quick question before you jump in, Philip.
Yeah.
There's a question in the chat, Karl, about, and it's a good question. Rob is asking it. How does the cracking software know that it actually hit the correct password? Like it's trying them one after the other, many thousands per second, but how does it know it was successful?
I didn't show this, but it copies the real database file and just does test it. It's a temporary file, just a copy of the database, and it sends all this passwords to the copy and tries it.
So it's really trying to open it using that.
It's
Got
trying,
it. Yeah. Okay, thank you.
You're welcome.
Okay, I think it's time for another demo, and a big shout out goes to Colin Riddington, who is Karl. I think you kind of messed up the screen at the moment. Not sure. Karl, can you stop sharing?
It needs a second until they get you back to the sharing screen.
Okay. Anyways, I'm going to show a demo that is based on cracking a super secure database that was created as a security challenge by Colin Riddington, known as Isla-Dogs, on the Utter Access and Access World forums. And he created a front-end back-end solution where both files are protected with a password. There are no linked tables. The password is stored in VBA and the connection is built to the database while the application's running. And on top of the built-in access encryption, he encrypted the data with a custom RC4 encryption in VBA. So I'm trying to show the demo. I hope you see my screen now. I tackle this from the point of view, I am a legitimate user for the database. I know the front-end database password. But please always keep in mind, even with the user with the lowest level of privileges, like only read, only access, and very limited privileges inside your application, he also needs to know the same database password as anybody else, because there is only one. And so I'm going to enter this here. And the application will open. So this is a screen. This allows us to view the encrypted data in the backend. That is the additional encryption he customized for his application. The database, the backend is unlocked with a password. So this is what you would get if you know the database password. So, of course, that is not meant to be used by the users. They have a nice form where the data is decrypted from the backend. And that includes some protection mechanisms. If I try to copy data, like to copy it to Excel or whatever, the application will intercept my Control C key, or if I try that, there's no context menu. So this is pretty much locked down. But I will show you how I get in here. I prepared a tiny other application that is using a tiny technique you are familiar with, but I'll show the details in a minute. What I do now, I select the file that is the front-end file for the protected application, and that is the running instance that I'm connecting here to. And I'm reading the list of open forms, and now I connect to the open form in the other Access instance and try to clone the record set. And here we are. This is all the data in there. It is decrypted because it was that way in the record set, and now it's under my control. I can just copy that to Notepad and just paste it in here, and that's all the data. So I kind of already stole the data of that form, but it gets even worse. I've got another button that is named Extract Metadata, and that contains a couple of the properties in the form, and particular this one is probably one Colin does not want me to see, because that is the password to the encrypted backend database. And another interesting bit is this one here. That is the decryption call for his custom encryption logic, and the term RMP4_key, that is actually the passphrase to decrypt the data in there. So I completely kind of broke into that database, and I'm going to show you how I did that. Let's just look at the code. It's really simple. That's something that you do as well. The first thing I do is I connect to the backend database. I just get the file name, and then I use getObject to get the running instance of Access running the protected database. And then I just loop, like you have done it 1,000 times. I loop through the open forms and get their names, and I just use them a minute later to go here. I get the form instance that's running there, and this is just setting up my display for it. The interesting bit is this one, clone record set. And if we look at the definition of that, that's totally simple. I create my own ADB record set, and then I loop through the records one by one and field by field, and just copy over the data and kind of have stolen it all. And now the final bit is to extract the secret password to the backend. I just once again grab an instance of either a report or a form, and then I just try to read some very common properties there, like the form name, the record source. From its record set, I read the name, the database name, and all that contains valuable information. And in this case, the record source is the most valuable because that included the encryption key as well as the database backend password. So I would like to remark, Colin improved this sample quite a bit in recent times, and it's more difficult to retrieve the data, but basically it's still working the same way.
You're done, Phil?
Yeah, I'm done.
Okay. So what else can you do to provide a secure access application? You could, of course, and should, of course, use an ACCDE. That means your source code is compiled, your modules, your forms, your reports are secure. The users can't make changes to it. Every object that holds a module is secure, but your tables, your queries, so all your data is completely unprotected. And it's still the current state, and the state for more than 10 years, I think now, that only Wayne Phillips offers a service to decompile an ACCDE. And he checks if you are really the owner of the database. So an ACCDE is quite secure. The next thing you could do is use the runtime version of Access. There are no design views in the runtime, so the users can't make design changes. There is no navigation pane, so the users don't have access to all the database objects. And there is only your predefined UI for them. However, the runtime doesn't prevent any external access to the data. So your data isn't secure in the runtime, and the user still can copy all the files over and open it up with the full version of Access, of course. So the runtime may be some secure method, for example, in a terminal server environment. Well, there would still be the VBA password. You shouldn't use it at all. It's so unsecure and so easy to remove. It only takes an hex editor, and you have to replace a single character and you're done. So it maybe takes you 1 or 2 minutes or 3 if you're unexperienced, but that's it with the VBA password. You can find all this at Google, and MVP colleague Daniel Pinot has a page with beautiful pictures how to crack the VBA password. It's really easy. So no problem at all, even for unexperienced people. Don't rely on it. What can you do if access and access files are not secure enough for your application?
Well, the obvious choice is to use a SQL Server backend for that. And there are lots and lots of features on SQL Server to secure your data inside the database. And it's a different ball game because nobody from outside the real server can get to the data files. And all must go through SQL Server. And I could talk like 5 of these presentations about SQL Server security, but we don't have time for that. So I would like to focus on a very important bit, which is basically the first step. It's the security of the SQL Server authentication, how you or your application connects to SQL Server. Just a real quick recap on the basic authentication methods. Windows authentication is the most secure way. The user is logged in via his Windows account. There is no communication between the client and the SQL Server, no exchange of passwords. That's just an authentication ticket that has been issued to the client previously, and he just sends that to the server. That's very convenient. The user does not need to enter his password. And also administrators like that quite a lot because most of the maintenance of the user accounts can be done in Active Directory after the initial setup. But it allows access to the SQL Server data from any application. And I'm going to talk about that in a second. The counterpart to that is SQL Server authentication. You use a username and password to authenticate yourself. And please keep in mind, if you want this to be secure via a remote network, you have to configure the server to enforce TLS encryption. And you have to use a real certificate for that issued by a proper certificate authority, not just an automatically generated self-signed certificate. Windows authentication and SQL Server authentication allow the server to identify each user individually. And the maintenance for the accounts here is done in SQL Server alone. And it also allows access from any application. So what's the big deal with access from any application? Is it a blessing or a curse? I rather think it is a blessing because it allows your users to have access to the database, to just fire up Microsoft Excel, connect to a view, get some data, create their own pivot table in Excel or a chart or whatever for their reporting purposes. And you don't need to bother with that. And the users are happy that they can use their familiar Excel environment to work with the data. And this is all no big deal if you created the business logic on the server that enforces all this data security on the server. That is something I've done a couple of times. And so I'm not that bothered because if the data needs to be really secure, that's what I would do. However, this is a lot of work for us Access developers because it involves creating stored procedures and triggers and locking down the access to the tables. And basically, for write operations, you lose all the standard data binding in Access when you just connect your table to a form and it's basically automatically read and write. You have to all write that functionality by yourself. So I can understand that people are worried about that because it would allow, otherwise users would be able to just fire up SQL Server Management Studio or even Microsoft Access and do that stuff themselves, create their own application working with the database of your application. So some people are very worried about that, and I understand it in some regard if you don't implement a strong security in the backend. So these people who are worried about that usually resort to one mechanism, the application login. That's basically SQL Server authentication, but not the user has the password. We embed the password inside the application, and the application will authenticate the SQL Server connection. But that means the individual user, the person using the application, is not identifiable by SQL Server anymore, and the application needs to connect with the highest privileges that are required for the highest privileged user of the application. And if you kind of think back to my demo where I broke the security of the Access application, that would be also applicable here. I would also be able to extract the secret application password from that application using the same automation technique I used previously. So I think this approach is a huge security risk. And in fact, my opinion is this is the most insecure approach of them all. So if you talk to someone who is not used to Access development about this problem, they would say there's an easy solution for that. Just use application roles. Application roles are a second level of authorization. You would connect to the SQL Server as a user, but the application would give you another set of roles implemented in that application role on SQL Server, and then the user would have additional privileges just when using this particular application, your application. Unfortunately, this does not work with Microsoft Access because Access creates lots of additional connections to SQL Server in the background, and you as a developer has no control about it. You don't even notice it. So there's no chance you can apply the application role that would limit the access from other applications. You cannot kind of apply that to each connection that Access kind of creates on its own. So we can't use it. And if the guys from Microsoft are still watching, I would like to ask them, please make this work, because that would be a really simple solution to this problem. Maybe there could be an ODBC connect event in Access that tells us whenever Access opens a new connection, and then we could apply the application role to that. So unfortunately, at the moment, this is not possible. But I would like to show you another quick demo. Well, maybe not so quick. And hang on a second. I need to share my screen here. So this is a simple login form with a server name, database name, and a SQL Server username. And I just enter my password, and it's quite intentional that you can see that. That is not a good practice in a real world application, but I want you to see it. So I hit login, and the form logs in and immediately executes a SQL statement to ask the SQL Server about the username and the database name. And here's the results to that. It's the security demo database I wanted to connect to, and my username is actually security demo user. So, okay, Then I will go to SQL Server Management Studio, and I just put my password into, copy the password and connect to this instance. And you see they are basically, it's the same connection info here. I just paste in my password that I copied over and I connect. And oh, what is this? Login failed. I cannot connect to this database. So what happened here? I'll show you. So let's look at the code behind this form. It's pretty simple. So here we go. This is the login. It's just a SQL statement, an ADODB record set, and then we use a SQL connection to execute and open the record set. And this is the interesting bit here. We go to the definition of SQL connection. It's just a box standard ADODB connection. And if that connection is closed, we call an open SQL connection method and pass in all the connection details, including the password. So far, that is pretty standard. But now let's look at the open connection method here. And there's something that is of importance here. I mangle the password. The user typed in Cascade 2020 and thinks that is his password, but it isn't. I used the rotate 13, that is a simple algorithm that just rotates the characters in the alphabet by 13. If you implement that in a real application, you should use something else. Any deterministic algorithm that can work with text strings will do. And so what this does is it creates another password, and that is actually the password of that SQL Server login on the SQL Server. And let's just try that. So I call that function in here and put in Cascade 2020. And this is what I get here. And now let's copy this over to Management Studio and try to connect again. I paste that in there and say connect. And here we go. This is the connection to the server. So, where's my clicker? So I hope you see the correct slide. No, not yet. Here we go. So what I did here is basically I built a sort of two-factor authentication mechanism. This is all based on SQL Server authentication, obviously, but it added a twist, a second factor. The user just knows his base password, what he thinks is his password, and that still identifies him as a person. And the application knows an algorithm. The application is the second factor here. An algorithm that needs to be applied to the user's base password to convert it to the real password that has been configured on SQL Server for this user. And as the user doesn't know his real password, he cannot fire up any application like Excel or SQL Server Management Studio and connect, as I showed you. So no more access from any other application to that. Of course, this would suffer from the same vulnerability that I exposed in my cracking demo. So I could still, as a user having a password and account, I could still fire up my automation database or a similar one, and would still be able, if I do that, to kind of maybe grab the real password that I need to connect. But still, it's more secure than embedding an application level password, because even if the user kind of broke into the database, he will still be identifiable as a person, and he will still only have his level of access. He will not have elevated privileges like the highest level privileges that the application offers, but only his level of privileges if you use different roles and sets of privileges on SQL Server, of course. So it's a huge improvement over the application password or application account. So we talked a lot about lots of technical stuff, but when you think about and work with data security and data protection, you should always keep another factor in mind. And that particular factor is this one.
So we essentially covered the left part here in the ring, but my money is always on Dave. And this is just some connection information to us, and we are open to questions.
That's great, guys. Thank you very much. There's been some chatter in the chat. One of the things that's going around in chat is for people to vote on user voice to vote for the item to make app role work from Access and VBA. And it's been, I know that's been a pet peeve of mine for a long time. I think I've begged, I think I'll characterize it as begging the Access team to do that. Kevin had a question with the rotate, the rotate function, Philip. How does, he was asking, well, so then how does the user change their password afterward if you're using that rotate function?
That is a very good question. For all the users, all the access to their user management should go through the application or at least through the algorithm. So when the user wants to change his password, he would also type in the password he knows, which is mangled by the algorithm. And then he would also type in his new desired password, which will also be passed through the algorithm and changed the same way. So it's always that the user has his password and the SQL Server has another one. And when the administrators create user accounts, they also need to use a functionality that kind of mangles the passwords in the same way.
Okay, so basically you apply the same algorithm as long as the user knows the old one and the new one, as many websites require you to do when you're changing your password, then you're okay. You can mangle them the same way.
Exactly.
Right, got it. Yeah, and of course, a lot of times people completely forget their password, so that you would probably have to build something else for, I completely forgot it, and then you have to use some other factor to be able to transmit it to them, like web applications do.
Yeah, sure. Most applications would not send the password the user forgot back to him. They would say,
right,
okay,
never.
reset the password. That is something that should be implemented in all applications. The application should not know the password. It should know how to validate it, but it should not know the password itself. And that is a mechanism you can easily implement in SQL Server, like you would reset the user's password with an administrative account, but you need to keep in mind to also then for generating the new password that you submit to the user to also apply that algorithm to change it into the way that the application uses it.
Right, yes, thank you. Adrian has a question. Can Access change the password for SQL Server?
Yes and no. Access on its own can't do it, but you can program VBA and custom queries either with ADO or with a pass-through query to change the password on SQL Server. I don't know the exact stored procedure or command. I guess it's someone like alter user change password or so. You would need to look that up in SQL Server documentation, but you can do that by sending a SQL statement to SQL Server.
Right, basically you can send a TSQL statement through to SQL Server if you craft it correctly. And as long as you have the authority to do that, it would do that for you.
Yes, of course. And the user, I think the user always has the I'm not entirely sure, but usually a user can change his own password. And an administrator can reset a password for a low privileged user.
Okay, thank you. I'm just looking through the comments. If there's anyone else that has any last minute questions, pop them in right now, because otherwise we will move on to our break. We got about 6 minutes left. If anyone has any questions, go ahead and put them in now. Any final thoughts, Karl and Philip? It seems like it's pretty interesting to develop a slide deck like this and these examples. What are your ending thoughts about access security, and when would you make the switch to like a web application if you needed a certain level of security?
Well, I personally wouldn't make security the factor to switch to a web application. I don't think security is the problem here, at least not in most cases. As I said, you can really lock down a SQL Server database to make it really secure. And I do that at least for really sensitive bits of applications that you cannot use access to directly modify data in tables, but just use stored procedure calls that implement the business logic and only allow the user to modify data in a valid way. And then I'm not too bothered by users firing up SQL Management Studio and editing data with SQL. If they want to do that, well, I'm fine with that, because I know they can only do valid changes to the data. So I'm not too bothered by that. I would rather switch to a web application if the users are distributed and want to use other devices like a mobile phone to edit data or whatever. That would be factors where I say, yeah, okay, then Access is probably not the right tool to build the front end for that.
Right. Got it.
We also provide more details in the white paper we already mentioned. So there is more assessment: when to use SQL Server, when to use, when is Access enough, and how secure do we find this Access all in all. I would just have a question for you, Armin. On your website, I saw that you consider Access not secure enough for HIPAA, but why exactly? Is it the one password thing, or what is it?
I don't think Access is actually, in my opinion, anytime a front-end application can have direct access to a database, it just is inherently not secure enough, in my opinion. I think that you can do, in my opinion, again, I think you can do a lot of work to try to make Access more secure, and you can keep adding on more and more concentric layers. But the inherent connection that it has directly to the database at the end of the day, it means that, in my opinion, it's less secure. However, I do think that there are a lot of smart people in this conference and you guys who have figured out ways to make the direct connection more secure. So I think that the benefit, of course, of Access is the rapid development and the lower cost of development. So unless you're spending so much extra time making it secure that you eliminate that benefit, right? There's some intrinsic security offered with like ASP.NET MVC, which we also build applications in, that I think if you do that right, it kind of is a built-in disconnect from the backend database, and therefore it can be made more secure more easily. Regarding HIPAA directly, I don't know enough about HIPAA to know for sure, except that I do know that if you can reach, if you can reach the database directly, then it's really a lot more difficult to do the full auditing that one might need to do for HIPAA, including read auditing. So that's one of the reasons that I say, you know what, if you gotta go to that level, then maybe Access isn't the correct tool. So it's a spectrum, though. I always think that it's like a gray area, and you got to find your way through that middle ground. And if you have the expertise to make it more secure, I think it's a good way to go.
And I know that Access is used everywhere, for HIPAA, for military, even for atomic plants. So, well, yeah, it's a gray area.
Yeah, that's one of the scarier things you just said. But yeah, okay. I agree. It's used everywhere, and I think that we all need to. What I like about your presentation is that and someone mentioned this in the chat of like, well, why don't you just move to web applications? The point is you need to know what you're dealing with. If you assume access is secure just right out of the box and the way you normally would develop with it, then I think you're making an error. What you really need to do is understand where the vulnerabilities are and what you're going to do to address them. And if you're not going to address them, or if it's not good enough for you, then switch to a different technology. But that's why we need a session like this to know where we stand.
Yes, absolutely. Because sometimes we all know that access applications grow organically, and I'm working on applications that have been developed over 10 years. If you would say we need to move that to a web application right now, it will take a year of development without any progress of new features, new stuff. And so this is not always an option. If you do that from the start, maybe I agree quite a bit with you, Armin. Then for super secure applications, it's probably better to use a web application right away. But so often access applications evolve over time, and you don't know that from the start what the requirements in 10 years will be. So we sometimes have to live with it and just make the best out of it. And if you can apply security, then we absolutely should do that.
Right.
And I think we have shown that in some aspects it's better than its image if you use it right in terms of security with database password, etc.
Right. And it's on all of us. The responsibility is ours to make sure that we are using it right. And I think the vast majority of access developers might put social security numbers or salaries or credit card numbers or nuclear plant codes into access databases and just think it's okay. And I think this kind of session is what we need to really be aware of, that it isn't just okay right out of the box. You need to take these measures. So
that was the
yeah.
goal.
Yeah, I really appreciate your guys' time. This is a great presentation. You're wrapping up the day, except for the social hour. So I'm really hoping everybody can tune in for the social hour. I will paste the link into the chat again. Yeah, in Europe, it's already way past happy hour time. Here, we're going to have to be day drinkers. But yeah, thank you very much, you guys. And I will paste the link into the chat for the social hour, and that'll be starting right at the top of the hour.
Thanks
All right. Thank you, everybody. I appreciate it.
Thank you. Bye-bye.
Bye.